Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Jamalullail bin Muhammad Hasri, and I will be presenting my final year project, which is the development of Tetherboard 3 indoor positioning system using radio frequency module. Problem statement. The current mobile robot indoor positioning system (IPS) utilize infrared sensors, cameras, and other additional hardware such as Lidar. These items stated are costly and require special hardware implementation. This project is done so that it can help students to have a more affordable alternative. For robot positioning system, this project focuses on making the system using accessible item. This will make it easier for other researchers to be done on different subject of localization, with Tetherboard 3 opening new ideas for the research community. Objective. The first objective is to develop an indoor positioning system using AD8318 radio frequency logarithmic detector module for Tetherboard 3, and the second one is to evaluate the performance and accuracy of the system by manually measuring the actual position of the Tetherboard 3. The methodology. The methodology is divided into a few sections, which is radio signal strength indicator, electronic use, signal receive, noise filtration using Kalman filter, distance algorithm, and lastly triangulation algorithm. Radio signal strength. So receive signal strength indicator (RSSI) is a measurement of the power present in a received radio signal. AD8318 RF logarithmic detector. It has the range of negative 65 dBm to positive 5 dBm. It gives the input in voltage, so Arduino can read it. 433 MHz radio frequency transmitter module as the radio frequency emitter. For the electronics use, the first one, this is the AD8318 RF logarithmic detector. This is the 433 MHz radio frequency transmitter module. This is only the emitter module. We will not use the receiver module. And the last one is electronics, the Arduino Nano for the microcontroller. Assembly and schematics. So for the schematics diagram for receiver module is using two AD8318 RF logarithmic detector with an Arduino Nano. As you can see, it will be connected to A1 and A2. This is the schematic diagram for emitter module. Next is signal received. For the signal received using the using only one AD8318, you can see it's give a bunch of noises, and you can see from the highlighted area the range of the noises is from 400 to 480. This is important to see after the noise has been filtered. So noise filtration will be using Kalman filter. So using Kalman filter, we remove the noise to about to make the line. As you can see there, it's from a bunch of noise in the later slide, in the before slide. In this slide, we can see the highlighted area. The noise is only in the range of 364, rather than from 400 to 480. It's now in 364 and 0.2 and until 364.9. Distance measurement algorithm. So to do the distance algorithm, we first need to have the input value for each of the distance shown in this picture. So this is the setup for the experiment. We choose to do it on 0.5 meter, 1 meter, 1.5 meter, and 2 meter. We choose 2 meter because before the assessment is done, we see what range does the receiver receive a good data from the emitter, and we have chosen 2 meter as the best result. So the common filtered data will be used to find the average of the data. At each distance, the average of different distance data will be put in a graph of distance against data. The graph will split into sections and calculate a formula to make an algorithm for distance measurement. The basic formula used is y equal mx plus c. As you can see, these are the data that we have received, and we make sense of the data and make a range, and using the formula y mx plus c, we find the m and c for a1 and a2, and using that we make the distance measurement algorithm. So for triangulation algorithm, we use this formula. This formula taken by the picture that you can see on the right side. It is taking 2 radius of a circle to find a point of interest which intersect between the 2 radiuses. So as you can see, C1 resembles A1 and C2 resembles A2 of the receiver. So to find the accuracy and evaluation for the experiment, we use this setup, which is to move the tetherboard in a square-like pattern. The result from the accuracy evaluation experiment deemed that the project has failed to reach its objective because we failed to accurately point out the tetherboard. As you can see, this is the result from the moving the tetherboard in a square-like pattern. This can be because of the distance measurement algorithm is not good enough for the positioning system, for the triangulation algorithm to use, because as you can see, the data has most passed beyond 2 meter, that which doesn't supposed to happen. This is the demonstration for how the receiver works and how it communicates with the Python. So as you can see here, the graph shows that it received the data from the emitter, and I've moved it closer to the receiver. As you can see, the graph of the red one is going downward because I push the emitter down to the bottom one, which is the red colored graph. So next is this is how the Python connects using to the receivers from the Arduino. It reads the serial data that the Arduino has given and use the triangulation algorithm to find the position. As you can see there, the position give out in text, which is the left one is X while the right one is Y. But as you can see, the triangulation couldn't make sense of the data taken from the Arduino because the distance is not good enough for the triangulation algorithm to find the position of the emitter, and thus give out the data as 300 meter. So that's all for my presentation. Thank you very much.